Hi students, welcome to SandM Coaching Center. We are doing the most expected questions from the chapter Introduction to Trigonometry. The first sum, prove that this should be equals to 1. So, we do not have anything on the right hand side, so we have to simplify LHS and arrive at RHS. So, let us simplify the LHS. Cosecant theta minus sin theta into secant theta minus cos theta into tan theta plus cot theta. This is the LHS. Now, the first step of solving the proof that other than sin and cos, whatever trigonometrical ratios you have, convert them into sines and cos. So, we will do the same thing. Cosecant theta can be written as 1 by sine. Sine, let it be sine only, sine theta. And then secant is the reciprocal of cos minus cos theta. Tan theta is sine theta by cos theta. Cot theta, cos theta by sine theta. Then within each factor, take the LCM. LCM of the first factor will be sine theta. This is, what is the meaning of this sine theta? Which means its denominator is 1. So the LCM of sine theta and 1 is sine theta. Now most of the children have problem in taking LCM. So I am explaining. Those who already know, they can fast forward the video. Sine theta, take the denominator. Denominator is sine theta. Sine theta into what will give you the LCM? Sine theta into 1. So, multiply its numerator with 1. Repeat the same process. The denominator is 1. 1 into what will give you the LCM sine theta? 1 multiplied by sine theta. So, what is the numerator? Sine theta. To that numerator, multiply sine theta. This is how you have to take LCM. Now, 1 multiplied by 1 is 1 minus sine theta into sine theta, sine square theta. Repeat the same process here. Cos theta, which means the denominator is 1. Then the LCM of cos theta and 1 is cos theta. Now, repeat the whole process again, children. Cos theta, whatever is the denominator, take the denominator. This denominator should be multiplied by what to get cos theta? Both are same, so it should be multiplied with 1. What should be multiplied with 1? The corresponding numerator. Repeat the process. 1 multiplied by what will give you cos theta? It is cos theta. So, multiply its numerator with cos theta. So, this would become 1 minus cos theta into cos theta, cos square theta. Now, what is the LCM? Cos theta into sin theta. Since both are different, the product will become the LCM. To cos theta, what should I multiply to get cos theta into sin theta? So, how do you identify? I have cos here. So, in the LCM, close cos. What are you left with? Sin theta. So, you should multiply the numerator of this with sin theta. Multiply it with sin theta. Repeat the same process. I have sin theta here. So, I will close the sin theta. What am I left with? Cos theta from the LCM. Which means the corresponding numerator should be multiplied with cos theta. Multiply. Sin theta into sin theta will be sin square theta plus cos square theta. What does it mean? 1 minus sin square theta. What is that? It is a identity, which means 1 minus sin square theta, you know children, is cos square theta by sin theta. Multiply it with 1 minus cos square theta is sin square theta by cos theta Sin square theta plus cos square theta. It's an identity. It is 1 by cos theta into sin theta. I have cos theta into cos theta, which makes a cos square theta. So I have a cos square theta in the numerator. I will cancel both. I have sin theta, both are being multiplied. So sin square theta, I have a sin square theta in the numerator. It will be cancelled. So what is that I am left with? I am left with 1. And what is 1? 1 is RHS. So I simplified the LHS, arrived at RHS. So what you will write at the end? You will write hence proved. The next sum, children. Prove that 2 sin power 6 theta plus cos power 6 theta minus 3 sin power 4 theta plus cos power 4 theta plus 1 is equals to 0. So the next tip, children, sometimes in trigonometry you may have to use your algebraic formula. So please read the algebraic formula thoroughly. Let us solve. What is the solution? First write the LHS as it is. Cos power 6 theta minus 3 sin power 4 theta plus cos power 4 theta plus 1 is equals to 0. Now write sin power 6 theta plus cos power 6 theta as cubes, which means I will keep the square brackets. I will write it as sin square theta whole cube. Sin square theta whole cube. What are we using here? Exponents. This is of the form a power 2 whole power 3, which will become a power 2 multiplied by 3, 6. So sin square theta whole cube will give you sin power 6 theta only. There is no change. Similarly, convert this into cube like cos square theta whole cube. Put it in a square bracket. Do not make any changes to this. Write this as it is 3 into sin power 4 theta plus cos power 4 theta plus 1 is equals to 0. Now, this is of the form, if you consider sin square theta as A and cos square theta as B, this is of the form A cube plus B cube. What is this? This is of the form A cube plus B cube. And what is the expansion of A cube plus B cube? It is A plus B into A square plus B square minus AB. A cube plus B cube is equals to A plus B into A square plus B square minus it. We will apply the same expansion here. So, this should be written as 2 into A plus B. What is A? A is sin square theta plus B. B is cos square theta into A square. Square of sin square is sin power 4. So this will be sin power 4 theta plus B square. B square is square of cos square. So cos power 4 theta minus AB minus sin square and cos square minus sin square theta into cos square theta. So we are done with the expansion of A cube plus B cube. Then write the rest of the terms as it is without making any changes. Sin power 4 theta plus cos power 4 theta plus 1. So the next step, 2 into what is sin square plus cos square? It is 1. So 1 into sin power 4. I cannot make use of any formula. So I will write it as it is, sin power 4 theta plus cos power 4 theta minus sin square theta into cos square theta minus, now apply distributive property to this. So it will become minus 3 sin power 4 theta minus 3 cos power 4 theta plus 1. That implies 1 multiplied by all these things, it will be 1 only. So again, I will apply distributive property. So 2 should be multiplied to each of the 3 terms. So this would become 2 sine power 4 theta plus 2 cos power 4 theta minus 2 sine square theta into cos square theta. Then write these terms as it is, minus 3 sine power 4 theta minus 3 cos power 4 theta plus 1. Now see, I have plus 2 sine power 4 theta minus 3 sine power 4 theta. So the answer would be minus sine power 4 theta. And then I have plus 2 cos power 4 theta minus 3 cos power 4 theta. So it would be minus cos power 4 theta. And I am done with this term. This term I am left with minus 2 sine square theta into cos square theta. And then this also is done, this is done. I am left with plus 1. Then I will write the plus 1 in the beginning. And then from all these terms, what is common? The rest of the terms, minus is common. So I will take minus and put the rest of the terms in bracket. So this is the sine power 4 theta. Since I took minus common, this would become plus cos power 4 theta plus 2 sine square theta into cos square theta. Now, if you notice properly, this looks like the expansion of a plus b whole square. What is this looking like? A plus b whole square, which is a square plus b square plus 2ab. How is it? Let us see. We will see. What is that I have used? I can rewrite sine power 4 theta as sine square theta whole square. Again, this can be written as cos square theta whole square plus this is again 2 sine square theta. I am not making any changes to this into cos square theta. So I have converted this expression in the form of a square plus b square plus 2ab, a square plus b square plus 2ab. So the expansion can be written as a plus b whole square. What is my a here? Sine square theta. What is my b? Cos square theta. So I will rewrite this as, this whole thing can be written as a plus b whole square. So my a is sine square theta plus b is cos square theta whole square. So I have written this whole expansion as a sine square plus cos square theta whole square. And what is that we know? 1 minus, this is identity, sine square theta plus cos square theta is 1. So 1 minus 1 is 0, which is my RHS. Hence proved. The next sum, children. Prove that sine power 4 theta minus cos power 4 theta plus 1 whole multiplied by cosecant square theta, we have to prove it to be 2. One more tip, children. If in the question you have any higher power higher than a square, then think of algebraic formulae. So let us solve. Write first the equation as it is. Sine power 4 theta minus cos power 4 theta plus 1 we are into cosecant square theta into cosecant square theta. Now look at this. How to write this sine power 4 minus cos power 4? You know that a square minus b square can be written as a plus b into a minus b. Why did we pick this formula only? Because there is a minus sign and I know I can convert sine power 4 and cos power 4 as squares. How can I do that? I will rewrite this as sine square theta whole square minus cos square theta whole square plus 1. Whole thing should be multiplied with cosecant square theta. Now this part is looking like a square minus b square. So we will write it as A plus B into A minus B. What is my A? A is sine square theta, B is cos square theta. So I should rewrite it in the form of A plus B into A minus B. A sine square theta plus B cos square theta. A plus B then into A minus B, which is sine square theta minus cos square theta, close bracket, and then put plus 1 as it is, close it with a square bracket, cosecant square theta. And you know sine square theta plus cos square theta is 1. So this will become 1 multiplied by sine square theta minus cos square theta plus 1 into cosecant square theta. What is this looking like? This looks like sine square theta minus cos square theta plus 1 into cosecant square theta. Now, if you look carefully, what is this? This is 1 minus cos square theta. And what do you know about the identities? 1 minus cos square theta, write it, we know that. 1 minus cos square theta is nothing but sine square theta. So now again I will use the identity here. This is sine square theta, I will write as it is sine square theta. This 1 minus cos square theta, I will rewrite it as sine square theta plus sine square theta whole multiplied by. Now how can I write cosecant square theta? Cosecant square theta can be written as 1 by sine square theta. So sine square theta plus sine square theta is 2 sine square theta. Divide it with sine square theta. So sine square theta is cancelled. So I am left with 2. What is 2? 2 is the RHS, hence proved. You simplify LHS, arrive at RHS. The next sum, children. We have to prove that sine A minus 2 sine cube A by 2 cos cube A minus cos A, we have to prove it to be tan A. So let us take the LHS first. Sine A minus 2 sine cube A by 2 cos cube A minus cos A. Now, in the numerator, the moment you see the numerator, what is very clear? It is clear that both the terms, they contain sin A. So, let us take sin A common. What is that you are left with? 1. Nothing, because you took the whole term common. So, nothing is left means 1 is there. And then here minus, from 3 sines, you took 1 sine away, which means you are left with sin square A. Repeat the same process for the denominator. Both the terms have a cos common. So I will take one cos A common. Here there are 3 cos A. Out of that I took 1 cos A out. So I am left with still 2 cos square A. And then completely I took this out. So in its place I will keep 1. What is that we have to prove? We have to prove it to be tan A. Sin by cos is tan. So what is our purpose? Our purpose is we have to somehow see that the 1 in the brackets, they get cancelled. So I will be left with the answer tan A. So how to do that? So sin A into 1 can be written as sin square A plus cos square A. Sin square A plus cos square A, right? And then minus 2 sin square A, I will write it as it is. Repeat the same process for the denominator also. 2 cos square A. And then how can you write 1 as sin square A plus cos square A? But because of the negative sign, this becomes sin square A minus cos square A. Do not get confused, children. Because of the negative sign, sin square A plus cos square A will become minus sin square A minus cos square A. So this will be sin A into, now see, sin square A minus 2 sin square A. So the result will be minus sine square A. So I will write this as cos square A minus sine square A divided with 2 cos square A minus cos square A. So I'll be left with a single cos square A and then minus sine square A. Now see, the one in the bracket is same for both the numerator and denominator. So I will cancel. I am left with sine A by cos A, which is my RHS. So what is that you can write? Hence, the next sum, children. Prove that cos A by 1 minus sin A is equals to 1 plus sin A by cos A. Now look at the LHS. Can I convert that into simpler terms? No. Already they are in cos and sines. I cannot. Can I use any algebraic formula like A cube and B cube, A square and B square? No, I cannot. Can I use the identities? There are no squares. So all these three tips, they fail here. What should I do? Okay, let me check the RHS. RHS also in simpler form. I cannot use anything to the RHS also. What to do? Then remember the next tip, children. See if you can rationalize the denominator. So let us see if we can apply rationalization here. Let me take the LHS. LHS is cos A by 1 minus sin A. Since all other tips failed, now I will see whether rationalization works here or not. What is rationalization? Whatever is the denominator, multiply both numerator and denominator with the same terms but with the opposite signs. So what is the denominator? 1 minus sin A. So I will multiply both numerator and denominator same terms but with the opposite sign. So I will multiply them with 1 plus sin A. 1 plus sin A. So this can be written as cos, the numerator can be written as cos A into 1 plus sin A divided with, now the denominator is the form A minus B into A plus B. So what is the A minus B into A plus B can be written as A square minus B square. Now we may use the formula. So I will write A square, which is 1 square, which is 1, minus B square minus sin square A. So this will be cos A into 1 plus sin A divided by, what is 1 minus sin square A? 1 minus sin square A is cos square A. You are using what? Identities here. What did you use here at this stage? Algebraic expression. Cos A and cos square A will be cancelled. So I am left with 1 plus sin A by cos A. Now what is this 1 plus sin A by cos A? If you look, it is nothing but your RHS. So RHS hence proved. The next sum, children. Prove that 1 minus sin theta by 1 plus sin theta is equals to secant theta minus tan square theta whole square. Now, look at LHS. LHS is in simpler form. Okay, we will leave it. Come to RHS. Yes, I can convert the RHS into simpler terms. So first what I will do, now I will simplify RHS and check whether we will arrive at LHS. This is the next tip. If you cannot simplify the LHS, what you can do? You can see if you can simplify the RHS and arrive at LHS. Solution. So what am I taking now? I am taking the RHS, which is secant theta minus tan theta whole square. Naturally, first convert the secant and tans into simpler forms. So this will be 1 by cos theta minus sin theta by cos theta whole square. Now, since the bases are same, I can write this as 1 minus sin theta whole square by cos square theta. Now I will rewrite the numerator as it is 1 minus sine square theta. Can I write it as 1 minus sine theta into 1 minus sine theta because it's the whole square? I can write it 2 times. Divide it with what is cos square theta? Cos square theta is 1 minus sine square theta. Cos square theta can be written as 1 minus sine square theta. And again, I will rewrite the numerator as it is 1 minus sine theta into 1 plus, 1 minus sine theta, and then again the denominator, it is of the form, algebraic form, a square minus b square. Whenever 1 is there, you can consider it as 1 square. So now the denominator is of the form a square minus b square. A square minus b square can be written as a plus b into a minus b. What is a here? A is 1, b is sine theta. So I will write it as 1 minus sine theta into 1 plus sine theta. If you notice, I have a common 1 minus sine theta, 1 minus sine theta, they get cancelled. So I am left with 1 minus sine theta by 1 plus sine theta. And what is this? This is nothing but your LHS. So if you simplify RHS, sometimes you may arrive at LHS. Hence, prove. The next sum, children. Prove that sin theta minus cos theta plus 1 by sin theta plus cos theta minus 1 is equals to 1 by secant theta minus tan theta. Now, let us look at the LHS. LHS is already in sines and cos. It is simple, so we cannot further simplify it. Now, see at the RHS. Now, RHS, it contains secant theta minus cos theta. What is the first thing that comes into our mind? That LHS, if it is not possible to simplify the RHS. Let us see if we can simplify the RHS and arrive at LHS. 1 by secant theta minus tan theta. So this can be written as 1 by cos theta minus sin by cos theta. So this can be written as cos theta by 1 minus sin theta. No, I have not arrived at the LHS. What to do? LHS I cannot simplify, RHS I cannot simplify. What to do? I cannot apply any identities, not even any algebraic form. How to simplify this? Then one important tip. In such situations, see if you can use the next tip, children. Now, if you notice properly, what is the denominator of the RHS? Denominator is both cos theta. Now, the tip says that if all other methods fail, see if you can divide the terms with either cos theta, sin theta. In this, I will see if I can divide the terms with cos theta. Why cos theta only? Because the denominators are in cos theta. I will see that. Yes, my previous method failed where I wanted to simplify the RHS. It failed. So now I will use a very important trick. And this is some children is very, very important. Not only because it has come twice in the boards in 2015 and 19. Not only because of that, but because of the fact that we are doing something new in this sum, which is dividing the terms by a cos. Solution. So I will take LHS sin theta minus cos theta plus 1 divided with sin theta plus cos theta minus 1. So what is that? I said divide all the terms of the numerator and denominator with cos theta. So sin theta by cos theta, it will be sin theta by cos theta minus cos theta by cos theta plus 1 by cos theta whole divided by, repeat the same process, sin theta by cos theta plus cos theta by cos theta minus 1 by cos theta. So this can be written as Sin theta by cos theta is tan theta minus 1 plus 1 by cos is secant theta by sin by cos is tan plus secant minus, sorry, sin by cos is tan plus 1 minus secant theta. So I will rearrange the terms and write it as tan theta plus secant theta. I will put this in a bracket and I will write minus 5 separately. And then I will write this as 1 plus tan theta minus secant theta. I did not do anything, children. I just rearranged the terms without changing the signs. Now, since I have a tan and a secant, what is 1 for identities? Secant square theta minus tan square theta is equals to 1. So 1 can be written as a secant square theta minus tan square theta. So I will write this as tan theta plus secant theta into, minus secant square theta minus tan square theta whole divided by 1 plus tan theta minus secant theta. Now this can be written as tan theta plus secant theta. I will write as it is, tan theta plus secant theta as it is. Now if you see carefully, this is of the form a square minus b square. What is this of the form? This is of the form a square minus b square. So it can be written a plus b, which is secant theta minus tan theta into secant theta plus tan theta whole divided with 1 plus tan theta minus secant theta. Let us continue the step. If you look at the numerator, I have two terms. This is one term and this whole thing is second term. I have tan theta plus secant theta common in both the terms. So I will take tan theta plus secant theta common. If I take common, what will be left over in this term? Nothing. Nothing means you have to write 1. Do not ignore. Minus this whole thing I took common. So I am left with secant theta minus tan theta. And write the denominator as it is. There is no change in the denominator, children. Okay. Now, write tan theta plus secant theta as it is. And then open the bracket here. So, it will be 1 minus secant theta plus tan. Divide it with 1 plus tan theta minus secant theta. Now, if you observe closely, you see that these two terms are same. 1 minus secant theta plus tan theta, 1 minus secant theta plus tan theta. So, they can be cancelled. I am left with tan theta plus secant theta. But is this the answer that we are looking for? No. The answer is something else. So, how to solve this? Now, first thing I will do is, I will rearrange the terms like secant theta plus tan theta, and this can be written as divided with 1. Now, listen to the next important tip, children. Now, instead of rationalizing the denominator, now I will be rationalizing the numerator. And the rationalizing factor will be the same terms but the opposite signs. So, the rationalizing factor will be secant theta minus tan theta. Multiply both the numerators and denominators with the same term. And how is the numerator? Numerator is of the form a plus b into a minus b. So I can write this as secant square theta minus tan square theta by secant theta minus tan theta. Now we know that secant square theta minus tan square theta is 1. So I can write this as 1 by secant theta minus tan theta. and this is what I am looking for, which is my RHS, hence proved. The next one, children. If cosecant A plus cot A is equals to 1, we have to prove that m square minus 1 by m square plus 1 is cos A. Okay, always start with what it is given. Given that m is equals to cosecant A plus cot square A, which means m can be written as 1 by sin A plus cos by sin A. If you take the LCM will be sin A. You can write it as 1 plus cos A. Value of m is 1 plus cos A by sin A. Now what is that? We need m square. So square it. When you square it on both the sides. So it will become 1 plus cos A whole square. Please do not square it separately, children, by sin square A. Now, the numerator is of the form A plus B whole square. So, A square plus B square plus 2AB, which is 2 cos A by sin square A. This is the value of m square. Now, find m square minus 1 value. M square minus 1 will be 1 plus cos square A plus 2 cos A by sin square A. This is m square minus 1. So take the LCM. So it would become 1 plus cos square A plus 2 cos A minus sin square A, divide it with sin square A, divide it with sin square A. Now see, 1 minus sin square A. What is 1 minus sin square A? It is cos square A. And then I have one more cos square A. Cos square A plus 2 cos A. Divide it with sin square A. So, m square minus 1 basically will be 2 cos square A plus 2 cos A by sin square A. Leave it like that. If we want, we will simplify it further. So leave it like that for now. We will now find the value of m square plus 1. Now we will find the value of m square plus 1. We already know m square value as this. So m square plus 1 will be 1 plus cos square A plus 2 cos A, divide it with sin square A plus 1. So this would be, take LCM. LCM will be sin square A. So on taking the LCM, it will become 1 plus cos square A plus 2 cos A plus sin square A. Now cos square A plus sin square A is 1. So 1 plus, there is one more extra 1 plus 2 cos A by sin square A. So this I can write it as 2 plus 2 cos A by sin square A. This is the value of sin square A. Now we have to find the value of m square minus 1 by m square plus 1. Then m square minus 1 by m square plus 1 is equals to 2 cos square A plus cos A, 2 cos A by sin square A. What is this? This is the value of m square minus 1. We have already solved it. Divide it with, what is m square plus 1? It is 2 plus 2 cos A, divide it with sin square A. So this will be What is common? 2 cos A is common. So take 2 cos A common. I will be left with cos A plus 1. Divide it with sin square A. And then division will become multiplication. Sin square A by, take 2 common. It will become 1 plus cos A. So I have 1 plus cos A, 1 plus cos A common, 2, 2 common, sin square A common. So what is that I am left with? I am left with just cos A. And what is cos A? Cos A is what you have to prove RHS. Hence LHS is equals to RHS. The next sum. If sin theta plus sin square theta is 1, we have to prove that cos square theta plus cos power 4 theta is 1. Okay, let us solve. This is very unique, children. Let us take what is given. Given is sin theta plus sin square theta is equals to 1. Now, what we have to do? We have to convert the entire sines into cos. So there is a hint given. If you notice, there is a 1 here and a sin square also. So what I will do, I will shift the sin square to that side. So it becomes 1 minus sin square theta. And you already know 1 minus sin square theta is cos square theta. So sin theta can now be written as cos square theta. Now, so I got cos square. Now I need to get cos power 4. How to get cos power 4? Cos square theta, how can it become cos power 4? Yes, by squaring it. So what I will do? I will square on both the sides. SBS, square on both the sides. So when I square on both the sides, sin theta will become sin square theta, cos theta will become cos power 4 theta. So now I got my cos power 4, and you know sin square very easily I can write it as 1 minus cos square theta, which is nothing but cos power 4 theta. Now take cos square theta to that side. So 1 is equals to cos square theta plus cos power 4 theta. And this is what they are asking. Next sum, children. The next sum, children. If cos theta plus sin theta is equals to root 2 cos theta, then we have to prove that cos theta minus sin theta is root 2 sin theta. Let us see how to do that. Always whenever these kinds of questions are given, we have to take only the given. So what is given? Given is cos theta plus sin theta is equals to root 2 cos theta. Now, we do not want roots. What we will do? We will square it on both the sides. Square on both sides. When you square on both sides, this will become cos theta plus sin theta whole square, which is equals to, when you square, root 2 will become 2, cos theta will become cos square theta. Now, this is of the form a plus b whole square. A square plus b square plus 2ab, so which is 2 sin theta cos theta, which is equals to 2 cos square theta. Now, you will be very much tempted to write cos square theta plus sin square theta as 1, but please do not do that, because we have to prove something else differently, entirely differently in this sum. So what I will do, on one side I have a sin theta. So I will keep this sin square theta here, shift the rest of the terms to that side. So basically sin square theta is equals to 2 cos square theta minus cos square theta plus 2, plus will become minus 2 sin theta cos theta. So this implies sin square theta is equals to cos square theta minus 2 sin theta cos theta. Now see, suppose if I have a sin square theta here on the RHS, imagine Suppose if I have a sine square theta here on this side, then this whole expression is of the form a square plus b square minus 2ab. So I can simplify it further, but what is needed? Needed is sine square theta. So in order to solve this, what is that I will do in the next step? I will add sine square theta. I cannot add only on one side, hence I will add sine square theta on both the sides. So sine square theta plus sine square theta is equals to cos square theta plus sine square theta minus 2 sin theta into cos theta, which is equals to 2 sin square theta is equals to, now how is that we have? We have cos first and sin second. So I will rewrite this as cos minus sin whole square. You can also write this as a sin minus cos whole square. But since we have to prove it as cos minus sin, I will take it in this manner. Now see, we are almost done with the sum, children. So what I will do is cos theta minus sin theta whole square. I'll just rewrite the equation as 2 sin square theta. Now what is that? I do not want the square of this. I just need cos theta minus sin theta. So cos theta minus sin theta can be written as a square. When it moves to the other side, it becomes a square root. So square root of 2 sin square theta. So basically cos theta minus sin theta is equals to square root of 2 into sin theta. This is what you have to prove. The next sum, children. If sin theta plus cos theta is P and secant theta plus cosecant theta is Q, we have to show that Q into P square minus 1 is 2P. In this sort of questions, always we have to make use of what is given. Given is P is sin theta plus cos theta. And then we have to find the P square value, which means P square is equals to square it on both the sides. So this will become sin theta plus cos theta whole square. So this would be sin square theta plus cos square theta plus 2 sin theta cos theta. You know sin square theta plus cos square theta is 1 plus 2 sin theta cos theta. Leave it like that. Then we will simplify what is Q. Q is secant theta plus cosecant theta. This I can simplify as 1 by cos theta plus 1 by sin theta. So the LCM of both of these is sin theta into cos theta. Cos should be multiplied with sin theta to get the LCM. So multiply this with sin theta, and sin theta should be multiplied with the cos to get the LCM. So multiply its numerator with cos theta. So the numerator would now be sin theta plus cos theta. So basically what is Q? Q value is sin theta plus cos theta by sin theta cos theta. Now we have to prove this term. Therefore, Q into P square minus 1. What is Q? Q is sin theta plus cos theta. Keep this in a bracket. Divide it with sin theta into cos theta. What is P square? P square is 1 plus 2 sin theta cos theta. And then there is a minus 1. So minus 1. Minus 1 plus 1 will be cancelled. Sin square, sin theta into cos theta, sin theta into cos theta will be cancelled. So this will be basically 2 into sin theta plus cos theta. And what is sin theta plus cos theta given as P? So 2P. So we have proved Q into P square minus 1 is equals to 2P. You write Hence, prove. The next sum, children. Prove that tan theta plus secant theta minus 1 by tan theta minus secant theta plus 1. We have to show it to be equals to 1 plus sin theta by cos theta. So, we know tan theta and secant theta actually are part of identity, which is secant square theta minus tan square theta as 1. So, 1 I will replace it with the identity. So, I am taking the LHS tan theta plus secant theta minus 1 by tan theta minus secant theta plus 1. What I will do? I will rewrite minus 1. What can I do? Minus 1 can be written as tan square theta minus secant square theta. So, this can be tan theta plus secant theta, and minus 1 can be written as tan square theta minus secant square theta. Divide it with tan theta minus secant theta plus 1. I am not doing anything to the denominator. Now, this whole thing is of the form a square minus b square. So, I will rewrite it using a plus b into a minus b form. So, tan theta plus secant theta, this I will make it as one term. And then I can write this as tan theta minus secant theta into tan theta plus secant theta. And the denominator I am writing as it is without any change. Tan theta minus secant theta plus 1. So, this would be, now if you notice, tan theta plus secant theta is common in both the terms. So take it out common. Tan theta plus secant theta. If I take it out common, I am left with 1 here, 1. So I will take tan theta plus secant theta common. I will be left with 1 plus here tan theta minus secant theta. The numerator write as it is tan theta minus secant theta plus 1. Now see, tan theta minus secant theta plus 1. Tan theta minus secant theta plus 1. Basically, these both are same. So, I am just left with tan theta plus secant theta. But is this my RHS? No, RHS is in terms of sines and cos. So, convert to tan. Tan can be written as a sine by cos. And secant can be written as 1 by cos. Since the denominator is both same, I can rewrite it as 1 plus sin theta by cos theta. I will write the denominator only once and add the numerators normally. This is your RHS and hence prove. Hence, we have to prove that 1 by secant theta minus tan theta minus 1 by cos theta as this. Now see, LHS contains secant theta and tan theta. So basically, I may try to convert them into simpler terms. But if you see again, RHS also contains same secant theta and tan theta. So what I will do, I will use a different procedure now. So LHS 1 by secant theta minus tan theta. What I will do, I will rationalize this part. So rationalizing factor, as you know, it has to be the same term but with the opposite sign. So I am rationalizing just one term. Yes, you can do rationalize one term and then write minus 1 by cos theta as it is without any change. So this would be secant theta plus tan theta by, and the denominator is of the form a square minus b square. So it will be secant square theta minus tan square theta minus, what is 1 by cos? 1 by cos is secant theta. So this step, and you know secant square theta minus tan square theta is 1. So basically this can be written as secant theta plus tan theta minus secant theta. So secant will be cancelled. I am left with tan theta. So on simplification, I came across tan theta. Let me now simplify the RHS. The RHS is 1 by cos theta minus 1 by secant theta plus tan theta. And what will I do? I will repeat the same process. I will rationalize just this one part. So the rationalizing factor is secant theta minus tan theta. So multiply both numerator and denominator with the same term. Secant theta minus tan theta. So this can be written as 1 by cos. What is 1 by cos? 1 by cos is secant theta minus secant theta minus tan theta, and the denominator is of the form a square minus b square. So it will be secant square theta minus tan square theta, which will be secant theta minus secant theta minus tan theta by, you know, secant square theta minus tan square theta is 1, which is secant theta minus secant theta minus into minus, it will be plus tan theta. Since 1 you can ignore, so this is your tan theta. And what is tan theta? When we simplified the LHS, we got the same answer. Therefore, you can say LHS is equals to RHS. Tan a plus b is root 3 and tan a minus b is 1 by root 3. We have to find the values of a and b. So let us write what is given. Tan of a plus b is root 3. And we know root 3 can also be written as tan 60 degrees, which means tan of a plus b is tan 60 degrees. So tan will be cancelled. So basically you are left with a plus b as 60 degrees. Take it as equation 1. Take the other value. Tan of a minus b. Tan of a minus b is 1 by root 3. And we know tan of a minus b can be written as tan of 30 degrees, because root 3 is tan 30 degrees. What does this mean? This means that a minus b is equals to 30 degrees. Let this be equation 2. Now see, I have two linear equations and the variables b they have different sign. So I can add equations 1 and 2. So what I can do? I can add equations 1 and 2. Add equations 1 and 2, we will get a plus b is equals to 60 degrees, a minus b is equals to 30 degrees. When you add, I am left with the 2a is equals to 90 degrees, which implies a is equals to 45 degrees. Find the value of b. A plus b is equals to 60 degrees. Out of that, I found out a value. So 45 degrees plus b is equals to 60 degrees. So when you take b to the other side, it becomes 60 minus 45. So b is 15 degrees. B is 15 degrees.